Hello everyone, welcome back to our class. For today's video, we are going to tackle about the constant and linear function. But before that, may I ask you to please bow down your head for a prayer.
Dear Lord, we thank you for the gift of life today. You allow us to have another day to praise you and see your glory. Thank you for the love and protection, especially this time of pandemic. Bless us, Father, with your wisdom as we begin our class. Help us to focus our hearts and minds on what we are about to learn. Inspire us by your Holy Spirit as we think and listen. Guide us by your eternal light as we discover more about the world around us. Lord, we thank you and let your will be done in our lives. We ask all this in the mighty name of Jesus. Amen.
Hopefully, at the end of this video, we are going to achieve the following learning objectives. First, define and differentiate a constant function and a linear function. Second, evaluate and graph a constant function and a linear function. Third, represent real-life situation using constant and linear function. So let's start with the constant function. Now, what is a constant function? A constant function is a function of the form f of x is equal to c, where c is a constant and any real number. And that can be represented as f of x is equal to c, where c is an element of real number. And when we talk about constant, it is a value that does not change whatever happened. Now, a constant function is a function having the same range for different values of the domain. Take note, the value of f of x will always be c and is independent of the value of x. If we have a constant function f of x is equal to c, each x value corresponds to one and only one element of y value, and the highest degree of the variable is 0. Now, let us always remember that a function f of x is always equal to y. Say for example, we have f of x is equal to 0, h of x is equal to 1, g of x is equal to pi, and we all know that the value of pi is a constant. That is 3.1416. Example number 4, we have f of x is equal to 3. Another one is y is equal to -5. And all these functions are a constant function because their degree or the highest degree of the variable is equal to 0. And that the value of c remains constant. So how are we going to find a constant function? First, we are going to check if it is possible to get different outputs or the value of y for different inputs or the value of x. If this is possible, then that is not a constant function because there are different values of our y, and a constant function should have one and only one constant depending on the given. Second one is, if it is only possible to get the same output or the value of y irrespective of what the input or the values of x are, then it is a constant function. So we only have to get one and only possible output or the value of y so that we can consider it as a constant function. Okay, so let's consider this function. Y is equal to x plus 2. So let us try to find out what are the values of our y, or is there any value of y, or there is only one value of y. So suppose we have the value of x is equal to 1. So to get the value of y, we are going to substitute the value of x1 to our function. So that is y is equal to 1 plus 2. And that is equal to 3. So, from that value of x, we have 3 as the value of y. Another, suppose we have the value of x is equal to 2. So, y is equal to 2 plus 2, and that is y is equal to 4. And from this example, since we get different outputs by varying the value of x, this is not a constant function. Remember, in this value of x, our value of y is equal to 3. And from this value of x, the value of our y is equal to 4. Therefore, there are different value of y, and that is not a constant function because a constant function has only one value of y from the given. Another one, for this example, we have f of x is equal to 3. Now, let's try to find out what are the values of our x and y. So, suppose we have the value of x as 3. Our y is equal to 3. And if we are going to have a value of x equal to 5, our y is equal to 3. That is fixed. In that case, y is always equal to 3 no matter what the value of x is. Since we can get different y values by varying the x values, this is now the constant function. So from this, always remember that f of x is equal to y, and that is the general form of a function. So in here, we have substituted x is equal to 3 and the value of our y is equal to 3. And now, different value of our x, y is equal to 3 still. So that becomes a constant function. Now, let's move on to the domain and the range of our constant function. As we remember, the domain are just the values of x, and the range are the values of y. Now, the domain and the range of a constant function differ because the domain of a constant function is equal to x such that x is an element of real number. And the range of our constant function is equal to y such that y is equal to c, where c is a constant. So that is the value of the range of our constant function. Now, how will we know that in a given graph, the domain is correct and the range is correct? For the domain, it comprises x values encompassed of the graph and y values encompassed of the graph. To understand further the domain and the range of a constant function, I have here a diagram that maps to the domain and the range of our constant function. So if we are going to have these values of x, we always have, or we get always the value of the range as constant. So whatever the value of our domain, that is always, or the range is always equal to the constant. It will never change based from the given function. Here, the graph of a constant function is a horizontal line, always a horizontal line. For example, we have this Cartesian coordinate plane, the x and y axis. So our graph will look like this. This is the graph of our constant function, horizontal line. And always remember that the graph of a constant function is always parallel to the x-axis. If we are going to talk about parallel lines, it will never intersect each other. Even how far we are going to extend that lines, they will never intersect. Let's move on to the graph of the constant function. For example, we have this f of x is equal to 3. If we are going to graph this in our Cartesian coordinate plane, we need to have values of x and y. And for the values of x, since our domain is an element of any real number, we can substitute any value of our x here. So suppose we have x is equal to -1, the value of our y is always equal to 3. Another value of x is equal to 2, and still the value of our y is equal to 3. And if we have x is equal to 4, the value of our y is equal to 3. Now, let us plot this in our table of ordered pairs so that we can easily get the point from our Cartesian coordinate plane. So we have 3 ordered pairs. We have negative 1 and 3, 2 and 3, 4 and 3. So let's start from negative 1 and 3. Plot it in our Cartesian coordinate plane. So here we have negative 1 and the value of our y is 3. And for the second point, we have 2 and 3. The value of our x is 2 and the value of our y is positive 3. And we have the next ordered pair is 4 and 3. So we have the value of x as 4 and the value of our y is 3. Again, y is the value of our constant, so that is constant. So if we are going to connect these points, we have this graph. The graph of f of x is equal to 3 looks like this, where the domain is equal or an element of any real number and the range is equal to 3. Now, for example, number 2, f of x is equal to negative 5. So, suppose our x is equal to negative 2 since we can substitute any value of x here because our domain is set or any real number. Y is equal to negative 5. And if our x is equal to 1, our y is still negative 5. And if we have x is equal to 4, our y is still negative 5. Now, let's plot it in the table of ordered pairs for us to easily identify the points that we are going to plot here in our Cartesian coordinate plane. So we have negative 2 and negative 5, 1 and negative 5, 4 and negative 5. So first, we are going to plot this negative 2 and negative 5 here. So, second point is the value of x is equal to 1 and negative 5 for the value of y here. And another point or the last point, the value of our x is equal to 4 and the value of our y is equal to negative 5. So if we are going to connect these points, we have this graph of f of x is equal to negative 5, where the domain are any real number and the range is equal to negative 5. So got it? Now let's proceed to the characteristics of a constant function. So always remember that all constant functions cut through the y-axis as per the value of their constant. And they do not cut through the x-axis as they are parallel to it. The constant functions are continuous as they represent horizontal lines that extend continuously on both sides without any break. And the value of y never changes no matter what value is substituted to the function. For example, we have f of x is equal to 3. If we are going to substitute the value of x is equal to 1, our y is still 3. And if we are going to substitute for the value of our x as x minus 1, still the value of our y is 3. And even if we are going to substitute the value for our x is equal to 1 million, our value of y is still 3. And that is the special characteristics of our constant function. Now, let's talk about the slope of a constant function. So why? Why is it that slope is equal to 0? Because a constant function is a linear function whose general format is y is equal to mx plus c, where m and c are constant. And remember that our constant function is equal to f of x is equal to c, or y is equal to c. And that can be written as y is equal to 0x plus c. As we remember the slope in this form, y is equal to mx plus b. And this m here is the slope. Therefore, from that, if our constant function can be written by y is equal to 0x plus c, our slope is equal to 0, in which it becomes constant because 0 times x is just 0 plus the constant. So that is how the constant function forms. Thus, the slope of a constant function is 0. So before we are going to proceed, let me give you these points to remember when we talk about constant function. First, the graph of a constant function is a horizontal line. Another one is the domain of a constant function is any real number, while the range of a constant function is equal to the constant. The value of a constant function never changes regardless of what value of x being substituted. And lastly, the slope of a constant function is always equal to 0. Isn't it amazing? Yes, let's move on to the constant function in the real world. So what are those examples that we can think of a constant function or that applies a constant function in reality? First, the price of any item at department store is 3 pesos and that is constant. In a book sale, the price of any book is 10 pesos. Next, an examination in which every student was given a star irrespective of how hard they all work. Another one, a bag worth 30 pesos is free for all purchases that go beyond 300 pesos. And lastly, a school canteen where every child was given one sandwich irrespective of their grade or age. Now, let us try to solve or let us try to construct a real-world problem involving constant function. Here, a telecommunication company offers an unlimited access to internet for a fixed amount of 1,499 a month. So, construct a function that shows the monthly bill given the amount of the data consumed. Now, we let y is equal to the monthly bill, which is fixed to 1,499. Next is x, that is equal to the data consumed by the customer depending on how they use the internet connection. So we have y is equal to 1,499 and that is just equal to f of x is equal to 1,499 and that's it. We already constructed a constant function based on the problem given. Now, let's proceed to the linear function. A linear function is in the form f of x is equal to mx plus b, where m is the slope and b is the y-intercept. And this is very familiar to us because this is already discussed in the lower years. So, to define further what is a linear function, the degree of a linear function is always equal to 1. And the slope should not be equal to 0. Why should the slope be not equal to 0? Yes, that's right, because the slope defines the inclination and steepness of the line. Once the slope becomes 0, the diagonal line will simply become horizontal line. Therefore, it becomes a constant function. Now, when we talk about the graph of a linear function, the graph is always a diagonal line. So to further understand a linear function, let us have some example here. One is f of x is equal to 3x. G of x is equal to x plus 2 and h of x is equal to 1/2 x minus 6. So all of these examples are linear function because they all have a degree of 1. Okay, so moving on, let's discuss about the domain and the range of a linear function. Again, always remember that the domain is the values of x and the range are the values of y. For this linear function, the domain and the range are the same. So the domain is equal to the set of any real number and the range is equal to the set of any real number. So when we are going to talk about its graph, to check if the domain and the range is correct, x values encompassed of the graph for the domain and for the range, y values encompassed of the graph. So let's verify that later on once we proceed to the graph of a linear function. For now, let's recall about the forms of the equation of a line being discussed to us in our lower years. So we have this standard form, ax plus by is equal to c, slope-intercept form, that is y is equal to mx plus b, the point slope form, that is y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Lastly, we have the intercept form, which is x over a plus y over b is equal to 1. But let us not focus everything about this. Let us just focus on the slope-intercept form, which is the y is equal to mx plus b. So to recall about the slope, as what I have said a while ago, this is the steepness of a line. And this is a section of a line connecting two points. For the formula of slope, this is just rise over run. Always remember the slope-intercept form, y is equal to mx plus b, where m is the slope and can be identified using this formula we had tackled in our junior high school. But let us not focus on this. I only want you to focus on identifying the slope and the y-intercept from the given linear function. So again, the slope-intercept form is y is equal to mx plus b, where m is the slope and b is the y-intercept. So let us practice identifying the slope and the y-intercept from the given example. We have f of x is equal to 3x plus 4. So what is the slope and what is the y-intercept? In here, our slope is equal to 3 and our y-intercept is equal to 4. Another one. Y is equal to negative 5x plus 1. So be careful with the signs. In here, our slope is equal to negative 5 and the y-intercept is equal to 1. So how about this example? We have y is equal to negative 6 over 7x. So our slope is equal to negative 6 over 7 and our y-intercept is equal to 0. How about this? Y is equal to 1/2 x plus 9. Yes, you're right. Our slope is equal to 1/2 and the y-intercept is equal to 9. Very good. Now, let's proceed to the graph of a linear function. So there are many ways in graphing a linear functions. One of these is using the slope-intercept form. So we are going to focus on this because we already discussed about the slope-intercept form a while ago on how are we going to get it. So to understand graphing linear function using slope-intercept form, let's focus on this example. We have y is equal to 2x minus 3. So for us to graph it in our Cartesian coordinate plane, we need to identify the slope and the y-intercept, since we are graphing a linear function using the slope-intercept form. So always remember that 2 here in this function is the slope and negative 3 is the y-intercept. Now, the slope here will identify our movement in the graph after plotting the first point. And it is better to represent it as a fraction because the formula of slope is rise over run. And since our slope here is a whole number, we all know that whole numbers are understood to be over 1. Meaning, in the numerator, this will identify our movement either upward or downward from the first point. We move upward when the numerator is positive and we move downward when our numerator here is negative. And so here, if our denominator is positive, the movement is to the right. And if this is negative, the movement is to the left. Now, how will we know how many units are we going to move up or down and left or right from the given function? The value of our numerator and denominator will identify how many units we are going to move up or down and left or right from the first point. Now, where are we going to get the first point to be plotted? That would be from the y-intercept. And from this function, our y-intercept is negative 3. Hence, it will be at point 0 and negative 3. If you already forgot what is y-intercept, that is only the value of our y when we are going to substitute 0 for our x. And in here, we have 0 as the value of our x, and negative 3 as our y-intercept. And this will be the first point that we are going to plot in our Cartesian coordinate plane. So now this is our y-intercept, the value of our y when our x is equal to 0. And since we only need 2 points to form a line, how are we going to plot another point? Now back to our slope, we need to follow the movement of our numerator, which is 2 units upward, and the movement of our denominator here, which is positive 1 and 1 unit to the right. In here, this is our second point. So if we are going to draw a line, this will be the graph of our linear function y is equal to 2x minus 3. And that is the diagonal line. And for the value of our domain and range, we have the domain is equal to any real number. And the range is equal to any real number. Moving on to another example, we have f of x is equal to negative 5 over 2x. So again, we need to identify the slope, and that is negative 5 over 2. In this function, there is no constant added or subtracted. Therefore, we can assume that the constant is 0, and that would be our y-intercept. Going back to the formula of our slope, that is rise over run, that is equal to negative 5 over 2. Since the numerator is negative, we are going to move 5 units downward. And since our denominator is positive, we're going to move 2 units to the right. Now, it's time to plot the first point using the y-intercept. Since the y-intercept is identified to be 0, so the first point would exactly be at the origin, the point 0, 0. So now, let's plot the first point. Here, the point of origin. So to plot the second point, we will use the formula for the slope. Here. So at this time, we need to first move 5 units downward. Since we have negative 5 as our numerator, here, and move 2 units to the right since our denominator is positive 2 here. Okay, so to the right. So our point 2 and negative 5 is our second point, this one. And if we are going to connect the 2 points, we can have the graph of the function f of x is equal to negative 5 over 2x. And of course, the domain is the set of real number, and the range is the set of real numbers here. Another way to graph a linear function is by using the table of values. So in using the table of values, we need to substitute random values of x to solve for y. Usually, 2 values of x, because we need at least 2 points to draw a line, just like here in this illustration. For example, we have y is equal to 1/3 x plus 5/3. So first, we need to find the value of x and y. And here, we supposed to have values of x, 1 and negative 2. So for us to find the value of our y, we substituted this value of x to the function. And if we are going to simplify this function, we can come up with the value of y is equal to 2. And for the value of x that is equal to negative 2, the value of our y is equal to 1. So we have the points 1 and 2 and negative 2 and 1. Now, let's plot these points in Cartesian coordinate plane. We have 1 and 2. Here, the value of our x is 1 and the value of our y is 2. So this will be our first point. And another point is the value of our x is negative 2 and the value of our y is 1. So this will be the second point. If we are going to connect these 2 points, we can have the graph of function y is equal to 1/3 x plus 5/3. The value of the domain and the range are the set of real number. Another example is y is equal to negative 2x plus 2. So for us to graph, we need to create the table of values. Substitute any real number to the value of x for us to find the value of our y. So in here, suppose our x is equal to 1, substituting it to x, that is, or the value of our y is equal to 0. And suppose our value of x is equal to 0, the value of our y is equal to 2. So we have 2 points, the 1 and 0 and 0 and 2. If we're going to plot these points in our coordinate plane, we have this point here and another one is this point here, which is the value of x is equal to 0 and the value of y is equal to 2. So connecting the 2 points, we will have this graph of the linear function y is equal to negative 2x plus 2. And to find out the domain and the range, of course, again, since the domain and the range of our linear function is equal to the real numbers, therefore in this graph or in this function, the domain and the range are the set of real numbers. So before we are going to end this video, let me give you some key points to remember when we are going to talk about linear function. The graph of a linear function is straight line. When the slope is positive, the line is increasing. When the slope is negative, the line is decreasing. We need at least 2 points to draw a line. And the domain and range of a linear function are all real numbers. And a linear function's degree is 1. Now, let's proceed to the linear functions in the real world. So let us try to have a situation wherein linear function is very applicable in the real settings. So we have a startup business spent 1,000 pesos on raw materials to make jewelry and sold each for 25 pesos. Suppose that he is not required to pay sales tax and the net income depends solely on the number of pieces sold. Then, construct a function that will show the net profit given the number of jewelry pieces sold. Okay, so to solve this problem, we let y is equal to the net profit and x is the number of jewelry pieces sold. So if we are going to construct a function that will show the situation from this problem, we will have f of x is equal to 25x minus 1,000. And that's it. So this will be our function. Now, let's differentiate a constant function versus a linear function in some cases. When we are going to talk about the form of a constant and linear function, this will be their difference. And the degree of a constant function is 0, while the degree of linear function is 1. The graph of a constant function is horizontal line and the graph of a linear function is diagonal line. And the domain of a constant and linear function is the same, the set of real numbers. While the range of a constant and linear function differ because the range of a constant function is equal to the constant, while the range of a linear function is an element of real number. Another one is the slope. The slope of a constant function is 0, while the slope of a linear function differs from the given function. Now, let's have an exercise. Identify whether the function is a constant or a linear function. Number 1, f of x is equal to 3. You're right, that is a constant function. How about this one? F of x is equal to 4x plus 2. Very good. That is a linear function. Another one is y is equal to 2x minus 2. Yes, that is a linear function because we are going to distribute these 2 in every terms here in our parentheses. So we will have y is equal to 2x minus 4. Another one. Y is equal to 4. Is this a constant function or a linear function? Very good. That is a constant function because the value of our y is equal to a constant 4. Another one is the g of x is equal to 6x minus 1. Is this a linear or constant? Yes, very good. That is a linear function. Now, let's identify the graph of constant and linear function. Number 1, we have this graph. Is it a constant or linear function? Very good. That is a graph of constant function. Number 2, very good. That is a graph of a linear function. Another one is, yes, that is a constant function because the graph is horizontal line and is parallel to our x-axis. Another one, number 4, is a constant function. Very good, because it is also a horizontal line. How about number 5? Yes, that is a graph of a linear function. A diagonal line that intersects the x and y axis. And now, let us check if our learning objectives are achieved. We had defined and differentiate a constant function and a linear function. Check. We had evaluate and graph a constant function and a linear function. Check. We represented the real-life situation using constant and linear function. Check. So if you are going to have some research for you to understand more about the linear and constant function, I have here our references. And that would be all for today. Goodbye, everyone.